Welcome to my comprehensive CCNA course. As this is the first video, allow me to introduce the course and tell you a little bit about what we have in store for you. This course is designed to be your one-stop shop for everything you need to ace the CCNA exam, and it's all completely free. We'll be diving into all the key topics on Cisco's official exam list, with lecture videos to guide you every step of the way. But that's not all. We also have practice quizzes to test your understanding, flashcards to help you review and remember what you learned, practice labs using Cisco's packet tracer simulation software, and multiple practice exams to get you ready for the real thing. And don't worry, while the course follows Cisco's official exam topics list, I'll also be providing additional context and information to really help you understand the material and improve your understanding of networks in general. This course is perfect for anyone who wants to pass the CCNA 200 to 301 exam. No prior knowledge of networking required and don't need any experience in programming. So, without further ado, let's jump right in. Now let's discuss networking. To begin, let's define what a network is. A computer network is a digital telecommunications system for sharing resources between computing devices that use a common telecommunications technology. Data transmission between devices is supported through data links made up of physical cables or wireless methods such as Wi-Fi or microwave transmission. The point of computer networks is to share resources such as information or printers. In the past, each person in an office would need their own printer. But with a network, a single printer can be shared by multiple people, reducing cost. Another example of resource sharing is file sharing, where a file can be transferred through SneakerNet, floppy disk, or USB thumb drive instead of physical transfer. The goal of a computer network is to make resource sharing more efficient and cost-effective. Networks come in all different sizes, from the smallest to the largest. The largest network on Earth that we know of today is the Internet. It connects people and devices all over the world. But networks don't have to be that big. They can be as simple as connecting two computers together. In the past, to share information between two computers, you would need to use a physical method such as copying files onto a USB drive and transferring it manually. Nowadays, networks typically use cables such as Ethernet cables to connect devices. One example is the use of a RJ45 connector, commonly known as an Ethernet cable, which connects devices through a physical connection. However, with advancements in technology, wireless methods such as Wi-Fi have become increasingly popular as it makes connecting and sharing information much easier. For example, connecting two smartphones together using Wi-Fi or Bluetooth instead of a physical cable is a common way people share information today. The idea of using cables like we used to might seem crazy to young people today, as they expect it to be easy and effortless to connect and share information across devices. Now let's talk about the two main players in the game, servers and clients. A server is like a superhero, providing all the resources and capabilities that clients need to access. Think of it like a big and powerful computer that has all the storage, memory, and processing power to handle multiple requests at once. But just like any superhero, it can't do it alone, and that's where clients come in. Clients are the sidekicks. They access the services provided by the server and make use of them. Imagine your laptop or phone as the client, reaching out to the server to get the information it needs. But just like the server, a client can also switch roles and become a server itself. It can share resources or host services for other clients to access. Now, let's imagine you're sitting in front of your laptop and you want to access Google. You type in the web address and hit enter. That's the client reaching out to the server, which is Google in this case, to get the web page. And boom, Google sends back the page and displays it on your screen. This process happens so quickly and seamlessly that we often take it for granted. The original Ethernet used a large yellow cable called 10^5. Repeaters were developed to amplify the signal, allowing the cable to be longer without signal attenuation. Multiple port repeaters, also called hubs, were also developed to repeat the signal from one port to multiple other ports. These devices did not understand the signal, they only amplified it. Nowadays, hubs are considered obsolete, but wireless access points, which allow multiple devices to connect wirelessly, can be considered a type of hub. A switch is a more advanced device that allows for multiple devices to connect and communicate on a network without collisions, unlike a hub. Switches are more advanced than hubs because they have the ability to forward and filter data based on the MAC address of the devices connected to it. This allows for more efficient use of the network, as well as greater security. When a device sends a data packet to the network, the switch will check the destination MAC address and forward the packet only to the port connected to the device that the packet is meant for. This eliminates the possibility of data collisions and improves overall network performance. Switch can come in different size with varied ports. Some switches are small with a few ports, while others have a large number of ports. Routers are devices that are used to connect different networks and direct traffic between them. They use routing tables and protocols to determine the best path for data packets to take as they travel between networks. Routers operate at the network layer OSI layer 3 and perform tasks such as IP address assignment, subnet masking, and network address translation, NAT. Routers can connect networks of different types, such as LANs and WANs, and can also be used to connect networks of the same type, such as connecting multiple LANs. One of the main functions of a router is to act as a gateway between different networks. In summary, routers are devices that directs traffic between networks. It uses routing tables and routing protocols. It can connect different types of networks and also can connect multiple networks of the same type. They come in different forms, from home-grade routers to enterprise-grade routers with more advanced features. A firewall is a security system that is used to prevent unauthorized access to a private network by filtering the incoming information from the internet. Its main purpose is to create a barrier between a private network and the public internet to protect it from hackers and malicious traffic. Firewalls block unwanted traffic and only permit wanted traffic, and it's especially important for large organizations that have a lot of computers and servers. A firewall works by filtering incoming network data and determining whether it should be allowed to enter a network based on rules called an access control list. These rules are customizable by the network administrator and can be based on IP addresses, domain names, protocols, programs, ports, and keywords. There are different types of firewalls, including host-based firewalls, which are software firewalls installed on a single computer, and many operating systems and third-party software come with built-in host-based firewalls. Another type of firewall is the network-based firewall, also known as a packet filtering firewall, which sits at the network perimeter and controls access to the entire network. This type of firewall inspects each packet of data that travels through it and allows or denies access based on predefined rules. Network-based firewalls can also be hardware or software-based and are typically used in larger organizations to provide more advanced security features such as stateful inspection, which tracks the state of a connection and ensures that only authorized traffic is allowed to pass through. Another type of firewall is the stateful inspection firewall, also known as a dynamic packet filtering firewall, which inspects not only the header information of a packet, but also the context in which the packet was sent, such as the type of data being transferred and the status of the connection. This allows it to detect and block potentially malicious traffic that may otherwise pass through a packet filtering firewall. Lastly, there are next-generation firewall, is a type of firewall that combines traditional firewall features with intrusion prevention, application control, and other security features to provide a more comprehensive security solution. Next-generation firewalls can also offer additional features like advanced threat protection and user identity management. In summary, a firewall is a security system that is used to prevent unauthorized access to a private network by filtering incoming information from the internet. Firewalls come in different types, including host-based, network-based, stateful inspection, and next-generation firewall, each with their own set of features and level of protection they provide, and they can be hardware or software-based. Thanks for tuning in. That's all for this video.